So good morning everyone. I hope all of you are doing fine. I welcome you all in my today's physical science class. This is our fourth class of class 9 physical science, and today it is going to be a very interesting class. So I want all of you to be very attentive. Okay, now let's start with our today's class. So this is the picture that I want to show to you. Now tell me what you can see from this picture. Yes students, right? Okay, this is an aeroplane, right? Now what is happening? Okay, now tell me in which direction is the weight of this aeroplane working, right? So it will be always being pulled towards the gravity, isn't it? So the weight will be applied in this direction, right? Very good. Now these are wings, isn't it? So these are generating lift. So lift will be generated in this direction. That's why it is flying. No, lift will be generated in this direction, right? Can you see this something? It is expelling something out of its tail. Can you see this? Right. So it is expelling something which is applying a force, and this force is also applying an equal and opposite force in this direction. That's why this plane is moving, right? So now we will be studying about this force only, right? We will be studying about this force, what we call this force, and how it is being useful to us. But before that, let's just see one more. Yes students, now there is one more picture for you. Can you see this picture? Yes. So what are there in this picture? Right. This is a pin. Very good. This is your finger, and finger is pushing the pin. Right. Now when the finger is pushing the pin, the direction of the applied force will be this one. But what is happening, as we know from the Newton's third law, action force will be always equal to the reaction force. So when you are applying a force on this pin is also applying a force on your hand, right? So the direction of the force in this case will be in the opposite direction, or we can, it is represented here by the black arrow, right? So from the Newton's third law, we know that every action has equal and opposite reaction, right? So now let's proceed forward. So basically, when we were dealing with the aircraft thing, we saw that it is expelling something out from its back end, isn't it? And it is moving in the forward direction, right? Aircraft is expelling something out of its back end and it is moving in the forward direction, right? So what it was expelling? It was expelling something that was creating a force, right? So when a system expels or accelerates a mass in one direction, the accelerated mass will cause a force of equal magnitude but opposite direction to be applied to that system. Right students? Like we saw that aircraft is pushing a mass of hot accelerated air in this direction. So this direction, when it is, when the force is applied, then what will be happening? It will be also applying an equal and opposite reaction force in this direction. And so what will be happening? The aircraft will be moving in further in this direction, right students? So whatever this thing is applied here, whatever this is applied or ejected from the back end of this aircraft, what we call it? We call it as thrust. So we can say that whenever something expels or accelerates a mass in one direction, the accelerated mass will cause a force of equal magnitude but opposite direction to be applied to that system, right? We also saw in our previous picture that weight of this aircraft will be acting in a downward direction, right? And these wings will be creating a lift in the upward direction. So when you will see this, this is approximately equal to the 90-degree. So we can say that the force applied on a surface in a direction perpendicular to the normal force. Here the important word is the force applied on a surface in a direction perpendicular or normal to the surface is also called as thrust, right? So the direction of thrust from the normal force will be what? It will be 90 degrees, right? So we know that it is the weight and it is the normal force, right? So this angle should be equal to what? This angle should be equal to 90 degrees. Very good, students. Now let's move ahead. So sometimes when we are in the sand, our feet is applying a thrust in a vertical direction, right? So the thrust is the net force acting on the surface and is always perpendicular to the surface on which the force is applied, right? So thrust is always perpendicular to the surface on which the force is being applied. Students, now there is a quiz for you. So just look at this quiz very carefully and try to answer this question. So the quiz states that the body moving due to thrust applied from the backward direction is moving forward because of the Newton's A first law, B second law, C third law, or D all of the above. What will be the correct answer to this question? Yes, students, I'm giving you 10 seconds to think about this question. Then we can go ahead with the answers. Right. So the answer will be the Newton's third law of motion. So the Newton's third law of motion suggests that every action has equal and opposite reaction. Right. So we saw in the case of aircraft also that aircraft was moving a mass of accelerated air in this direction. Right. And it was moving in this direction, right? So this mass of moving air was producing a thrust, and that thrust helped aircraft push it in opposite direction, right? So now let's proceed ahead with our next model. So students, let's see this picture, what you can see from this picture. Yes. Okay, so someone is squeezing the lemon, right? And for squeezing the lemon, what we need, and to squeeze the lemon, we apply something called as pressure, right? What is pressure? Let's see. We will be learning in this module about the pressure itself, right? Pressure only, right? So basically, pressure is the force applied perpendicular to the surface of an object per unit area over which that force is distributed, right? So suppose that this is the area where this is the area upon which the force of F is applied. So the pressure will be equal to what? Pressure will be equal to force per unit area, right? So the pressure is the force applied perpendicular perpendicular to the surface of an object per unit area over which that force is distributed. So this is the formula. P is equal to thrust by area, or we can say pressure equals to force per unit area, right? So what is the SI unit of pressure, students? Okay, right. So the SI unit of pressure is Newton per meter squared, right? Newton per meter squared. Now let's move ahead. Yes. So now in this slide we can see a quiz. This quiz is for you guys. So you need to find thrust and pressure. So what is given? The, the question reads as the square box of mass 10 kg is placed on the ground having a side equals to 5 meter. So now you need to find thrust and pressure, right? I'm giving you 10 seconds. After that we can solve together. Okay, so now we know that thrust is nothing but just the force, right? So we know that force equals to mass times acceleration. So we can say force equals to 10 kg into 10 meter per second square. We can say 100 newtons of force or thrust is being applied by that square box. Now we know that pressure equals to force or thrust per unit area. So now when we will solve for this, then what it will come, let's see. When we will solve for pressure, it will come, force is already 100 newtons or thrust is already 100 newtons, right? And when we divide it by 5 into 5, this equals to 25. So the pressure will be equals to what? Pressure will be equals to 4 newton per meter squared, right? So the value of thrust will be equals to what? It will be equals to 100 newton, and the value of pressure, this will be equals to what? It will be equal to 4 newton per meter squared, right? So let's move ahead, students. So students, you might have seen this type of purse also and this type of bag also, right? So the basic difference in these bags is that it is used to carry small loads. This bag is used to carry small items, right? But you can really load this bag and carry a lot of objects in this. So is there any reason why this bag is such designed so? Yes, students? Right. So this bag has a wider strap, right? So this bag is having a wider strap. When you will put this strap on your shoulder, then what will happen? It will apply less pressure. See, this is the bag and this is the strap, right, students? Okay, so similarly, what we will do in this module is we will see the uses of pressure or the application of pressure in our daily life. Okay, so we have already saw about the first thing, that the broad shoulder strap bag, what happens? What happens to them? They apply less pressure and they feel more comfortable even when we are carrying a much larger weight, right? But if the strap is very thin, then that strap will dig into our skin and it will really cause pain. So let's see some of the uses of the pressure. Okay, students, so you might have seen that when a knife is sharp, we can cut fruits, vegetables, salads with it very easily, right? But as we go on using that knife, then what happens? The knife becomes dull, isn't it? The knife becomes dull, and it is really very hard to cut fruits and vegetables with a dull knife, right? So it is one important application of pressure, right? Another thing is that whenever you will see a nail, you will find it that it is designed in this way, right? It is having a body, then it is having a very pointed tip, and then there is a flat head, right? So any nail is designed in this way only, so that whenever a force is applied from this direction, the point of area of contact will be very less, so that it can easily dig into the substance that it is being nailed into, right? So similarly, when you will see the tires of the tractor, the back tires of the tractor, you will find that those tires of the tractors are really very broad, right? And those broad tires prevent the tractor from sinking in the ground. Okay, students? Right. Now suppose this is a cushion, right? This is a cushion and this is you. You are standing on this cushion, right? So now you will observe that this cushion, like it bends to this extent, right? But suppose that you are not no longer standing on this cushion, you are just lying flat down, right? So this cushion is not bending down so much, it is bending down very gently, right? So what might be the reason? The reason is the pressure. Okay, students, understood? So these are some applications of pressure in our daily life. So we can see pressure in our daily life from these examples. Now let's look at this picture. Can you see this picture, students? Yes, this picture, right? You might have seen some people wear heels, isn't it? Some people wear heels, and when you wear shoes, right? So when you are wearing a heel, then what will be happening? Weight from the heel shoe is spread over the smaller area. See, the area of contact is small, right? And thus it exerts a higher pressure on the ground. But when you wear a shoe, then what happens? When you are wearing a shoe, then the area of contact is larger. As a result, the pressure is lower. Always remember, students, pressure is always defined as force per unit area, right? So the pressure will increase if the force will increase, and pressure will decrease if the area of contact will increase. Okay, students, right? So shall we move ahead? Okay, right. Now this is a quiz for you. So the quiz states that for constant pressure, if force increase, the area must be dash, right? For a constant pressure, if the force increase, the area must be dash. I'm giving you 10 seconds to think about this question. After that, we can solve this together. Right. So now let's try to solve this question. Okay. So we know that pressure equals to force per unit area, right? So it is saying that the pressure term is constant. It is not going to change, but the force has increased, right? So the force has increased and the pressure is not changing. Then what will happen to the area, students? Pressure is, we can say, pressure is directly proportional to the force, and pressure is inversely proportional to the area, right? So if the force has increased, the area must also increase, so that the pressure must remain the same. Okay, students, right? Understood this point? So the area must increase. Right. Now let's move ahead to our next question. Next portion. So we have reached the end of our today's class, but before ending, so now let's just quickly recap whatever we have studied in our today's class. So in our today's class, we have studied about thrust and pressure. We have studied about thrust and pressure. So first of all, let's differentiate between thrust and pressure. So thrust is basically a force which is applied by a mass of moving air or moving accelerated particles that pushes something in opposite direction. So thrust, we can say, it is basically a force. Thrust is equal to the force, right? And pressure is defined as the force or the thrust per unit area, right? So what is a thrust? Thrust is the force applied by an accelerated mass of moving body, right, in the opposite direction, right? So now, what is the formula of pressure, students? Right? Tell me, what is the formula of pressure? Okay, we can write the formula of pressure as P equals to F by A, force per unit area, right? So now let's give some examples of pressure that we see in our daily life. Okay, so first of all, we saw that it is hard to cut with a dull knife than with a sharp knife, because in a sharp knife the tip is very smooth, the tip is very fine, right? And we can apply more pressure by applying less force also. So therefore it is easier to cut with a sharp knife rather than with a blunt knife. The second example of second illustration that we saw was of the tires of the tractor. The tires of the tractors are broad so that they apply less pressure and they do not dig into the soil, right? They do not get stuck in the soil. Okay, the next application of pressure we saw was when we wear heels. Then what is happening? We are applying more force that is spread over the less surface area, right? So the pressure increases. But when we are wearing shoes, then the area of contact increases and the pressure decreases. Right. Now, what is the example of pressure, students? Right. So, when we are applying force by our feet, right, that is also an example of pressure, isn't it? Yeah, because the weight of our body, whenever we are standing on the ground, the weight of our body is pushing the ground, right? So, and the point of contact is our feet, right? So, it is also example of the pressure. You can also think about some examples of the pressure on your own. Okay, students? Right. Now, this is the homework for you. The homework is that woman is wearing a sharp heel. The mass of woman is 40 kgs and the area of heel is 1 centimeter square. Then you need to find out the pressure that she is exerting while walking. Okay, students? Right? Okay. So that's all for today. Have a nice day, students. Thank you.